Welcome to Revised Chemistry with Mr. B. In this video, I'm going to show you the chromatography required practical. Later in the video, I'm going to show you how to analyse chromatograms and also how to calculate our F values. So the first stage of chromatography is we get a piece of chromatography paper and we mark a start line about 1 centimetre from the bottom of the paper. And it's really important we do that in pencil, because if we used a pen, that pen would also dissolve in the solvent and start to work its way up the paper. I then mark B and G on here because I'm going to have a brown sample and a green sample. So the first brown one I'm going to use is a felt tip pen, so I just need to dab that on the start line. The green though is liquid ink. So to use this liquid ink, I'm going to use a capillary tube, a very thin glass tube, and I'm going to just dab it in there, wipe off the excess, and then dab a sample of that on the start line. You can let it dry and repeat the process to make the colour more concentrated. I've now suspended the chromatography paper with the samples on it using a wooden splint with the paper clip. I've just wrapped it round a few times around the top to get the length right so that the paper is about 1 millimetre off the bottom of the beaker. I'm then going to add a solvent so the bottom of the paper gets wet, but I'm going to be very careful that I don't put so much in that it goes up anywhere near the start line. We can see the solvent's moved up the chromatography paper, so we call that the mobile phase, whereas the paper itself is called the stationary phase. This pattern of results is called a chromatogram, and the colours separate because the ones that move higher up the paper are moving faster. That's because they're more soluble in the solvent. So we could say they've got a greater attraction to the solvent and less attraction to the paper. So they've got a greater attraction to the mobile phase and a less attraction to the stationary phase. When the dyes have almost got to the top of the chromatography paper, we take the paper out of the solvent and we mark on it with a pencil how high the solvent reached, and we call that the solvent front. And that's important for when we start working out our F values. We're now going to start analysing some chromatograms. So it would look like this in your exam paper, just in black and white, so you can't see the actual colours that have been separated. And the question could say, 4 different pens, A, B, C and D, were analysed using chromatography. What do the results tell you? So first of all, we're going to have a look at how many spots have moved up the paper, and that tells us how many components or dyes were in each ink pen. So we could say pen A contained 2 dyes because there's 2 spots. Pen B was made from just 1 dye and pen C was made from 3 dyes. The ink in pen B is a pure substance because it's only got 1 spot, whereas the ink in A and C were mixtures. And if you need a reminder about the difference between a pure substance and a mixture, I'll put a link up here now to a previous video. We then start matching the heights of the dots of how far they've moved up the paper. So the dye in pen B is the same dye found in pen A because it's moved the same height up the paper. Similarly, we can say the ink in pen A contains the same dye as B and also one of the dyes in pen C. Now we need to talk about pen C. So we can say pen C has 1 dye the same as A and 2 others not found in the other pens. Now pen D is different, that's not moved at all from the start line. So we can say the dyes in the ink did not move because they were insoluble in this solvent. If you wanted to find out the colours in this pen, you'd need to find another solvent that it is soluble in. At this point, if you think you've learned something from the video, please do give it a like, and that way I know what people are finding useful and I can make more videos like this one. So we're going to work out some RF values now, and you need to remember the formula, which is the distance moved by the dye divided by the distance moved by the solvent. So the question might be calculate the RF values of each dye. So if we look at the orange dye first of all, distance moved by the dye divided by distance moved by the solvent, you'd actually physically measure it with your ruler in an exam unless it's given in the question. So in this case, we've got 5.8 is the distance moved by the dye, divided by 7.4, which is the distance moved by the solvent, and that comes out at 0.78, and there's no units for RF value. If we then work it out for the blue dye, the distance moved by the dye is 2.7, divided by 7.4, which is the distance moved by the solvent, and this time the RF value is 0.36. So if you've liked the video, don't forget to subscribe to my channel so you don't miss out on future videos. Thank you for watching.